Devlog number 4. I don't have a whole lot to show this week. I had plans, but things took a turn, and I ended up somewhere I didn't expect to be. So I'll talk about what I've been doing. Forewarning, there's going to be a lot of highly technical programmer talk in here, so prepare yourselves as appropriate for that. So I was working on this battlefield layout thing that I've been doing for the last couple of weeks. And I had a situation where I realized that if an ability is input, targeting a champion on the opposing team or on your own team, and nobody is standing there where you're targeting, I needed to perform a search for the nearest valid target to redirect that ability onto. And the way that search needed to happen was pretty complicated. It had to take into account the range of the ability and some aspects of what it does and a whole bunch of stuff. So anyway, I ended up with a mostly implemented, pretty complicated search function that I didn't have a whole lot of confidence in because it has enough edge cases and weird things about it that I didn't feel good about just putting it in there and testing it manually and calling it good. So I really wanted some unit tests for it. I wanted to be able to call that function in isolation with a whole bunch of different inputs and just verify that it works in a wide variety of cases. So then I realized I didn't actually have any unit tests in this project at all. Brief summary of what unit tests are if you don't know. They're pretty much a way to exercise parts of your code and make assertions about it to verify that it works as expected. So I put in controlled inputs, run the actual code that's supposed to process those inputs and do something with them, and then get outputs out and verify that the output is what I expect. This has a whole bunch of benefits. It gives me ongoing verification that I haven't broken anything in functions that I test. It lets me completely change their insides, and as long as they conform to the appropriate interface and give the right output for whatever input I put into them, then it doesn't matter how they work on the inside from the perspective of workingness. I can do optimizations, I can just do a completely different implementation on the inside, and unit tests will tell me that I haven't broken anything. So they're really nice to have. A bunch of other benefits, I won't go too deep into them, but anyway, I'm a proponent of unit testing, and it was kind of a problem that I didn't have any in this project. So that's abnormal for me. Usually when I work on a project, I like to write tests first. So I do test-driven development when it seems appropriate. Sometimes this doesn't work for games, sometimes it does. This particular game has a lot of very input, operate on it, output in fairly isolated cases, patterns in it, if you see what I mean. So definitely quite a few candidates in here for testing. So, I wanted to write a test for find champion nearest to position and range. That was the big complicated function. However, there were a bunch of things upstream from there that also needed to be tested. So battle state model involves a bunch of champion state models, and it calls formulas. I showed you that formula, like for the fire spell. You can see exactly how that's calculated. I'll show you a little more detail in that in a moment. Player inventory, that's involved in this somehow. Scenario data registry, scenario state model. Actually, this is not involved. There's a couple of unrelated things in here that it just really looked like should have tests too. So I'm taking a moment to go and get my unit test suite built for everything that needs it, so that I can be sure that all the implementations of things that I'm using for these complicated functions that are important to the game are actually fully done and working the way I expect them to. How I ended up in this situation with no tests in the project is that basically I was going into a lot of this with a prototype mindset. I just create, okay, so here's a champion state model. Here's a champion state model. I'll implement the functions for, when somebody takes damage, here's how I think that should be calculated, and dampened by elemental responses, and, protection, what events that'll dispatch to other parts of the code, whatever. Just kind of put something together, see how it works, and expect to change it later. Eventually, that matured enough for me to no longer consider it a prototype. But where it evolved to had no unit tests driving it. So what I would normally do, here is a unit test suite. I'll just use this one as an example. For example, I'm testing the formula calculate function here. When you pass it 0 and 4 nulls, it should return 0. When you pass it 5 and 4 nulls, it should return 5. So test-driven development, instead of, implementing formula calculate to the best of my ability, then writing a whole bunch of these and seeing how many of them pass, what I would do is I would write just like a couple of these. So assert 0 and nulls equals 0, 5 and nulls equals 5. I would stub out, this would not actually be in the unit test file, this would be in the source file for formula over here where the real implementation is. But anyway, just as an example, I would stub out a function like this, where I would just return, do no work at all, return some token value just so this would compile, and then write the tests and run them. So I would see that this test, which passes at a 0 and expects to get a 0 returned, would pass because that's just the fixed value that this returns. Then I'd write this line, and when I pass it a 5, I would not get a 5 back. So this would fail. So, I would run this. Every time I compile, my unit tests compile and run, so I can see immediately if I've broken anything. So, I'd compile this, see the tests run. I didn't actually save that file, right? I shouldn't have. This is really slow on this computer for some reason. Anyway, so I would see formula test, something failed on some line. I don't have any of these failures in here. All of them are just, these are test cases I know I still need to write. So I just put this stub assert in here because I still need to write them. But anyway, I would see an assertion failure. I would get a line number and everything, so I would know exactly where to look. It would say expected a value of 5, but got 0 instead because this returned 0. So, I'd say, okay, well, that test failed, so why don't I do this? It looks like my tests are demanding that I just return the first parameter, 0 equals 0, 5 equals 5. So I'd do that, rerun this, and see that particular test pass. So in witnessing that process, seeing that that test failed, making a change, then seeing the test pass, I know that this line tests my real code, this thing that's actually used in the rest of the game. It verifies that it has this behavior that I specify here in the unit test. So that's the benefit of test-driven development. I know that my unit tests work. So anyway, then I'd write a few more tests. I'm using the second parameter here. And when I pass a 5 to it with these things in the structure that I'm passing here, I expect a 0 back. So then this test would fail. Right around this point, I would have to try to write a real implementation of in here of this and actually do the work that the function is supposed to do. And then just iteratively continue that process until I have a full implementation with a full test suite that covers every case of input that can go to this function to affect its output. Anyway, so that's what test-driven development would look like. But I've landed in a situation where I have a mostly working implementation of formula calculate and all the other functions that I'm testing, where I'm just making a bunch of assertions and hoping that they test the right thing. They're probably fine. After the fact unit tests are less valuable than ones written before, but still quite valuable. So I've already uncovered several bugs and oversights with this, including some crashes. So it's important stuff. Anyway, so by stopping to add tests now, this allows me to solidify sort of half-baked decisions that I kind of sort of think I know what I'm doing with, but when I have to assert this input equals this output and try to cover all the cases, then I have to actually solidify the decisions that I'm making about how my code works. So a concrete example of this would be how elemental response works. So every attack in my game carries an element with it, or it can. You can have a non-elemental attack, or you can say like, okay, so the fire spell is a fire elemental effect that decreases the health resource by 3, or whatever the number is. There are formulas, which is actually what this is testing, for adjusting that 3 damage. If you have some fire resistance, for example, maybe that would dampen it down to 2. If you absorb fire, maybe that would actually heal you by 3. I had to think about stuff like, what does it mean to have a fire elemental healing ability? How would that affect my my damage calculation formula? So anyway, things like that. I hadn't really thought of all the edge cases, had kind of a halfway implementation of them. I'm actually having to answer those questions and have all of that solidified. Anyway, so it's giving me confidence that I've handled all the edge cases and my code's going to perform as I want it to in the full game. Anyway, so unit tests are cool. They do a lot of cool stuff. They're kind of like doing paperwork. It's a big slog. I have to write a lot of lines of assertions, test all of the different cases. But once that happens, then I can have a lot of confidence in the thing that is tested, that it will behave exactly as I want it to in all cases forever. And any change I make to it, it'll immediately yell at me whenever I compile that, hey, you broke something in here. You need to go fix it right now, or else your thing will not finish compiling. Anyway, so what this is testing is my formula evaluator. So I did show this a little bit. I'll show you what it looks like in the scenario file. So I could open the game, but I'm not actually sure it would run right now. It should. Let's see if I can actually show this. So if I open this, I didn't quite plan around this. Oh boy, I don't even have the, okay, can I look at fire spell? Decreases health by 2. So right, here is the in-game representation of that formula. Let me see if I can get these side by side. So we got add to result 2. Right, so spells, fire, that's its name, that's its icon, that's what sound it makes, all that stuff. It reduces a resource, the resource of health, in the target by this formula. So add to result 2, add const 2, add to result actor's focus stat. If the target count, which is a special value here, you know, the number of things you're targeting with it, is greater than 1, and that condition is true, then evaluate this formula. You will divide, while rounding up, by 2. If target count greater than 1, divide result by rounded up 2. So what this describes is that your fire spell has a base damage of 2, and any point in focus, the focus stat for the champion, which the mage starts with 1, will increase its base damage by 1. So fire will then do 3 damage. But if you're targeting multiple things with it, then it's going to divide the damage that it does by 2 while rounding up. So if it does 3 damage cast by a mage, then it's going to do 2 damage to everything you target. I also have a truncating divide, so you could make it do 1 damage if it multi-targeted. Anyway, so this is the input to the formula evaluator. Whoops, not that window. Which is the code under test here. So this, let me show you the header file. It's a little more readable. I can use these operators. I can use these types of operands. Like the actor stat of focus is what is added to the power of the spell there. So anyway, I just have this generic evaluator for this mathematical operation that can have any number of steps to it, which comes out ultimately with an integer. So, I input actually, I usually just input 0 to this, but, it comes along with the formula, which has its own base value here. I think this parameter is the actor, this parameter is the target, this parameter is a value table, which includes stuff like the target count. This is just a special value that is set by the function that calls the evaluator for where the fire spell goes off. Anyway, so all of those things feed into this system, which can just perform an arbitrary calculation with that. Anything you want can go in here. So that's a great candidate for a unit test because it's very self-contained, has very defined inputs and outputs. A place where I would set this to something non-zero is like elemental damage adjustment. So you get an input value of, hey, I'm taking 5 damage in this element. What do I need to do to adjust that based on my resistances and stuff? Anyway, so that's all one of these formulas. So scenario development, the thing that I will do to put together my main scenario, the thing that you will do if you want to make a custom scenario for this game, will involve writing these formulas, or just pulling from a library of them. If you don't want to do the math and stuff yourself, just use a template. But if you can have your damage calculations and stuff behave in any way you want mathematically, and that will all be revealed to the player because you can inspect the formula and see all the details of that. So I think that's super cool. I may have built more flexibility than I strictly need into that, but I like having the full flexibility. Anyway, so again, unit tests. So I want to test this by putting all sorts of values into this using, use the assign operator, use the add operator, use the subtract operator, everything that is specified in this header file that you can do to a number is exercised here and test it to make sure, here is a formula that multiplies its input by 3. You use the multiply operator with a constant value of 3. You feed it a 5 and you better get 15 out. You feed it a -2, you better get -6. So this makes sure that all of that stuff works. And, it gets more complicated for the stuff like reading, actor stats, for the focus and stuff, like with the fire spell. I have to make up a bunch of champion records that have... let's not get into this part. I'll probably talk about the technology behind this another time. But anyway, just unit tests verify that when I call this function, it does what it's supposed to do. So, I have a lot more tests to write. I have written about 5,000 lines of unit tests in the last week or two, and probably a little past the halfway point to have all of these done. I want to see all of these say, like, scenario data registry test. This one is done. Ran 5 tests, 5 test cases, succeeded with 1,049 asserts. This is 1 assert. So that's how many are in that. Scenario state model test needs to do a bunch of stuff. Mostly I just want to make sure I get the things upstream from battle state model. So champion state model needs to be done. That one's close. I just have one thing to wrap up there. Formula is almost done. A couple of things involved there. You could wait. You could wait. And even you could wait. Okay, so maybe I'm closer to done than I thought. All right, so yeah, I am on pace to probably have these in a reasonable state by next week, so that I can at least get back to working on the battlefield grid. I don't know how close that will be to done, but at least I will be done with my detour and ready to get back to it. So anyway, little look at some of the technical insides of this code. Yeah, I'll see you next week with hopefully something a little more exciting.